Hello student, in this video we will be going to discuss about a new topic and which is given in our chapter number 6, that is sequence and series. So students, let us come to the topic of sequence and series. Before going to the topic of sequence and series, let us try to understand the actual meaning of the sequence, then we will move to the series and then we'll go for the question and answer sections from the exercise. First of all, let us come to the sequence. Students, if I will write some of the numbers 2, 4, 6, 8, 10 and so on, if you will observe these numbers are arranging in a particular definite rule. The first number is 2, then we will get the another number 4, then after this we will again get the another number 6, then after 6 we are again getting another number 10, and the particular pattern is going in this way only. If you will observe here, with each term 2 is added and the next term is there. Again with this term 2 is added, then the next term the 6 is here. Again here 2 is added, the next term 8 is here, and again if the 2 is added, the next term 10 is here. So students, if any arrangement of numbers are following with the particular rule, then the set of arrangement of these numbers are said to be on sequence. So students, I am repeating the definition of sequence once again. When a set of numbers of or algebraic terms are arranged according to a definite rule, then these algebraic terms are said to be in sequence. I am going to write you another example of the sequence so that you can understand better. So students, if I will write 1, 5, 9, then I will write 13, then 17, then 21, then and so on. If you will observe these numbers, they are also in a particular pattern. See, after 1, another number is there, 5, which is 4 added to 1. Then you will get 9, again 4 added to 5, then again 13, 4 is added to 9. In this way, this particular sequence of numbers are going on. So students, again I am repeating, if the numbers are arranged with the particular definite rule, then the orders and this arrangement of numbers are said to be in sequence. So we can write down the different examples of sequence also. For example, 1 square, 2 square, then 3 square, then 4 square, then 5 square, 6 square, and so on. So if you will observe these types of numbers also, first 1 square, then again the same 1 added, then square, then 3 square, 4 square, 5 square, 6 square. So the definite arrangement of the numbers with a particular pattern is known as the sequence. Now students, I am writing one example of the sequence. Let us see here. 1, then 5, 9, then you will 13, then you will get 17, and so on. Look at here students. This is the first number of this particular sequence, and this first number of this particular sequence will be called as the first term. So these numbers are called the terms of the sequence, and whoever in the first position, the number is called the first term. 5 is the second term of the particular sequence, 9 is the third term of the particular sequence, and 13 is the fourth term, and so on. 17 is in the fifth term, and it will goes on. So generally, if you will see students, these are the first term, second term, third term, fourth term. If you will denote all the sequence in a particular T, then the first term will be denoted by T1, and similarly the second term will be denoted by T2 and the third term will be denoted by T3 and similarly fourth term is denoted by T4 and fifth term is denoted by T5 students. So generally if you want to say all the sequence that you want to write in a particular arrangement, then we can write down the sequence in a particular arrangement as the sequence is always written in T and. That means if you want to write T1 as a first term, then it will be T2, then it will be T3, then it will be T4. Sometimes also it is written as a string UN. UN means it is again the n means n number of terms are there in the particular sequence, and this if you will put 1, then you will find the U1 means it is the first term, again in the U2 it will be the second term, then U3 it will be the third term, then U4 it will be the fourth term, and it will goes on. So I hope students you have understood this particular brief of the sequence. Now based on the number of terms students, we can classify the sequence into mainly two parts. So look at here students, I am writing some of the terms sequence here 1, 2, 3, 4 and 5, and I will write here student 1, 5, then 9, 13, 17 and so on. Look at here student, if you will go to the first particular sequence T1, T and you will find that here n is 4. Sorry, 1, 2, 3, 4, 5. N is 5. So where the number of terms are countable, then the sequence are said to be finite sequence. When the number of terms are countable, that means finite, then the sequence are said to be finite sequence. And when the number of terms are uncountable, that is infinite. Here in this case 1, 5, 9, 13, 17 and so on, means how many digits, how many numbers are there in this particular sequence, we cannot count. So in such cases this type of sequence are said to be infinite sequence student. These types of sequence are said to be infinite sequence. Now student, after sequence we will be going to move to the next topic, that is series. So let us come to the particular topic of series. So students, we have already known that 1, 5, then it will be 9, then 13, then 17, then 21 and so on. These numbers are in a particular arrangement and these numbers are known as a sequence. Now, what is actually the series code? If you students, each term of this particular sequence, if you will arrange by the addition sign, this sequence will be converted into the series. So the only difference between the sequence and the series is that sequence are the numbers written while the series are the terms whose addition is there. So here it was 1, 5, 9, then 13, then 17, then 21 was there and so on. But students, if this is the sequence, if you will write this sequence in a particular with the addition sign, this sequence are said to be in series. So students, if somebody asks you what is sequence, the sequence means the arrangement of a number in a definite rule, and the series means the sum of the arranged number in a definite rule is known as the series. And students, do you know this series is called the finite series or infinite series based on the number of terms of this series. If the series have the finite number of terms, then the series is called the finite series, or if the series has the infinite number of terms, then the series is called infinite series. So again students, I am repeating the same thing about the sequence and series. Try to understand. The numbers that are arranged in a particular arrangement, these are called the sequence. If we will write the terms of this particular sequence by the addition, then the sequence will be converted into the series. And students, based on the number of terms of the series is called the finite series, and based on the number of terms of the sequence, if this is the countable number of terms, then we can call it as a countable sequence and countable series. If these are the uncountable, means infinite number of terms, then we call is an infinite series. Now students, let us understand another topic. Suppose student, there are these terms in a particular series. It's very easy to find out the sum 1 plus 2 plus 3. Yes, we can count the numbers and we can add and we can find the sum of this particular numbers, that is 1, 2, 3. That means what? 5, 6. The sum of this particular number is 6. But students, whenever there are large number of terms in this particular series, at that time it's very difficult to count the sum of this particular series. Then the sum of the particular series is rationalized and written in this form. By using this particular symbol, the Greek symbol, which is called the sigma. This Greek symbol is called the sigma, and this is called the summation. The summation means the sum of all the terms of the series. Here it is A1 plus A2 plus A3 plus A4 plus A5 and so on up to the AN. Then we can write down this one as, suppose there is a first term starts from 1 and goes up to N. Then we can say that summation R from 1 to N, then the particular series is AR. That means what? The sum of this particular series can be written in this form, that A1 plus A2 plus A3 plus A4 plus A5 plus A6 up to AN. Then the summation of this particular, all the terms of this particular series can be written by the Greek letter sigma, where R means how many terms are there based on this number of terms. R goes from 1 to N. AR, that means A1 for 1 number of terms, A2 for 2 number of terms, A3 for 3 number of terms, A4 for 4 number of terms. I hope students you have understood this particular meaning of this symbol, Greek symbol sigma. Based on this Greek symbol sigma, we are going to discuss about another example. Let us move to the another example of this. Students, if I will write down the symbol R goes from 1 to N and it is R square. So from here also we can find out the value of this particular series very easily. So that here R goes from 1 to N. That means here first was 1 square, summation 2 square, then again summation 3 square, then up to 4 square, then plus dot as on up to N square, because R goes from 1 to N. So R starts from 1, 2, 3, 4 and so on up to N square, because the summation of R goes from 1 to N to R is square. So this summation can be written in this series, student. I hope students you have understood the meaning of series and sequences, whatever we have discussed it here. Now we are going to move to some of the questions from the exercise 6.1. So let us take the first question of the exercise 6.1. Here in this first question, students, we are asked that find the first 7 terms of each of the sequence. The first sequence is given. Here students, try to understand, it is the sequence. Sequence is in the generalized form -1 to the power n. Here we need to find the first 7 terms. First 7 terms of the sequence. So students, in the generalized form, the sequence is written here. So how we will find out the solution to find out the first 7 terms of this sequence? If you will find out the first term like in this way, first term will be -1 to the power 1, because n means number of terms and number of terms means the first term is 1. So -1 to the power 1, negative to the power odd number means it is -1. Similarly students, if you will go to the second term, you will find out second term is equal to -1 to the power 2, negative to the power even number, and you will find out the answer +1. So and so on. The third term will be written in this way student. Third term means -1 to the power 3, because and the number of terms, so number of term will be our third term, and third term will be written as -1 to the power odd number, it is -1. So similarly, if you will go to the fourth term, fifth term, sixth term and seventh term, we will definitely get the terms of fourth term, fifth terms and sixth, seventh terms in this way student. So finally, after getting the answer, what will be our answer of this particular question of 1a? Look at here. The first seven terms of the particular question of 1a is -1 was the first term, +1 is the second term, -1 is the third term, and then +1 will be the fourth term, then -1 will be the fifth term, then +1 will be the sixth term, then finally -1 will be the second term of the particular sequence that we are given, -1 to the power n student. I hope students have understood the question number 1a. Other questions of this question number 1 we will be going to discuss in our class. This is all about today's video. We will be going to meet in our next video in our next day. Thank you student.